Welcome back again, solving numerical problems from work energy power. I hope by now you have watched the previous two videos where I explained the concept of work done by a constant force and did few numericals also. And let us solve another numerical problem. Problem 4, meant for your JEE main and NEET examination, not for JEE advanced. So this time the position vectors are in I cap, j cap and k cap, so that will be difficult to show in a two-dimensional figure, but I will still try to explain you it better. So the statement, the problem goes like this: a body of mass 2 kg, mass is given, is acted upon by two forces. F1 is equal to 2I cap plus 3J cap Newton, means this force has a component along x-axis as 2 Newton and the force F1 has a component along y-axis as 3 Newton, because I cap is a unit vector along x-axis, positive x-axis, and J cap is a unit vector along positive y-axis. Now the second force, the same mass 2 kg is acted upon by another force simultaneously. F2 is given as minus 2I cap plus 3J cap Newton. This many Newton. Let me write N here. Means this force F2 has 2 units along negative x-axis and 3 units along positive y-axis. Now, under the combination of these two forces, the body is displaced from position A is equal to 3 meter minus 2 meter and 1 meter from this position to position B is equal to, let me put it here, and to position B is equal to 1 meter plus 2 meter minus 3 meter. This is the initial position, this is the final position. Then what is the work done? Now, so to begin with, since the forces are given in their components, so we can straightway add them without using parallelogram law of vectors. So what is the combined effect of these two forces? So that will be your F1 plus F2. Now that is equal to F1 is given as minus 2I cap plus 3J cap plus F2 is 2I cap plus 3J cap. So minus 2I cap plus 2I cap, they cancel. So 3J cap, 3J cap, 3 units along y-axis, 3 units along y-axis, so they can simply be added. So the combination of these two forces is equivalent to a single force, 3 plus 3, 6 J cap Newton, right? So let that be F. The combined effect of these two forces is 6 J cap Newton, means this much force is acting on the body of mass 2 kg, and due to that the body is displaced from position A is equal to 3 meter minus 2 meter 1 meter to position B is equal to 1 meter 2 meter minus 3 meter. Now x component, y component, z component. So the position of A cannot be shown in a two-dimensional figure, but I can explain you. A is equal to 3 units along x-axis. From here to here is 3 units. Then 2 units along negative y-axis, 2 units to this side. So I arrive at the point somewhere here. 3 units, then 2 units. I arrive here, then 1 unit along positive z-axis, means from this point vertically upward, means the point A is not lying on this plane from this point at a vertical distance 1 unit. At a vertical distance 1 unit means it will be like this. It will be like this from this point at a vertical distance 1 unit here. So the position vector of A from this point is not lying on this plane. It is, let me take a different pen. Is not lying on this plane. Rather it is like 3 units to this side, 2 units to this side. I arrive here, then I have to move up a vertical distance of 1 meter. So your position vector for the point A is from this point, like this, not lying on this plane. So I cannot draw a line in space here. So let that be, that point A is represented by position vector RA. So that will be how much? 3 units along x-axis, so 3 cap, minus 2 units along, minus 2 units means 2 units along negative y-axis, means minus 2 j cap, 1 unit along positive z-axis, plus 1 k cap, that is same thing as this. Similarly, the position vector B, let it be RB. Let me explain, then it is very simple. 1 unit along positive x-axis, 2 unit along positive y-axis, and 3 unit along negative z-axis. So 1 unit to this side, then 2 unit to this side. I arrive here. Then from this point vertically downward, that is the negative z-axis, that is minus 3. So means the point B is also not on the plane of the paper, but from this point vertically downward at a distance 3 meters. So the position vector of B can be represented as 1 I cap, that is equal to I cap, plus 2 j cap, plus 2 j cap, minus 3 k cap. And I have explained you, as I have explained you in previous videos, what is the displacement vector therefore? So the displacement vector is therefore RB minus R of A, that is equal to this minus this. So that is equal to I cap plus 2 j cap minus 3 k cap, minus of this, that is equal to minus 3 I cap plus 2 j cap minus k cap. So this is your displacement vector. So this becomes I cap here minus 3 I cap here. So minus 2 I cap. Now plus 2 j cap plus 2 j cap. So that is equal to plus 4 j cap minus 3 k cap minus k cap is equal to minus 4 k cap. So this is your displacement vector, and this is your force vector. Force is constant. So therefore work done. So your W will be equal to F dot, the displacement vector, that is equal to F dot, same thing as RB minus RA. Now if we just calculated as 6 j cap dot RB minus RA we calculated as minus 2 I cap plus 4 j cap minus 4 k cap. Now it is simple. Now it is simple. 6j dot minus 2i, since j and I are perpendicular, so the dot product of 6j cap with this is 0. 6j dot 4j will be equal to 6 4s are 24. J dot j is equal to 1, so 24 into 1 is 24. Then 6j dot minus 4k, since j and k are perpendicular, because this is j cap is along y-axis, k cap is along z-axis, so angle between them is 90, and in dot product we take cosine of the theta, cos 90 is 0, so the contribution of 6j with 4k is 0, so this is the work done. So this is the work done, and since the force was given in Newton and the displacement was given in meter, so 24 joules of work is done. So now let us then go back to the next problem. I will gradually move on from smaller problems to bigger problems, complicated problems. In the next videos, I will be discussing work done by a variable force, then how to apply conservation of energy, kinetic energy, potential energy to different situations to solve the problems. Now let me come back to the next problem, numerical 5. Now, this is also a good problem for JEE main and NEET, not for JEE advanced. A cord is used to lower a block of mass m. I have shown it here. This is a block of mass m by a distance t. It is lowered by a distance t, let's say from this point to this point, at a constant downward acceleration g by 4, means 1/4 of the acceleration due to gravity. Then the work done by the cord on the block. Then this cord is doing how much work on the block. Now, since it is coming down with a constant acceleration g by 4, so mass times this is constant, and this is constant, and therefore force is constant, since F is equal to m times A, and A is your constant g by 4, so this is a constant force. So we can apply this. Now, so we can apply this. Now it has moved down by a distance, let me show it here, it has moved down a distance, from here to here, a distance t. Now then how much is the work done? Now if you look at, there are two forces acting on the mass. Its weight vertically downward and the tension in the cord vertically upward. Since tension is always away from the mass, because by taking a string or a cord you cannot push something, you can pull it. Since this is going downward with acceleration, so the value of mg must be more than t. Then there will be a net force downward, and since there is a net force, there will be acceleration downward. So then what do you write? So mg minus t is the net force on this mass m, that will be its mass times acceleration. Acceleration is given as g by 4, so I put it g by 4 here. So your t comes out to be mg minus mg by 4, so 4 mg minus mg, so is equal to 3 mg by 4 is the tension, and this tension is to this side, and the displacement vector is to this side, and angle between them is 180 degree. So angle between them is 180 degree. So your work done using this expression, since the force is constant, so your W is equal to T times the displacement cos of 180 degree, that is minus 1, that is minus TD. So minus t. For t you write as 3 mg over 4 times d. So this much is the work done, minus 3 mg d over 4, right? So if tension is given, expressed in Newton, and the displacement d is given in meter, then this many joules of work is done, right? So okay, so that's all about. In the next videos I will switch on to work energy theorem and how to apply it in different situations. So keep watching, and soon I will be uploading videos from engineering mechanics as well very soon, by this weekend. Thank you.